All right, looking at section 4 on our geometry section, we are looking at segment rays, parallel lines, and planes. Okay, so we're going to be looking at what these are, kind of introducing them, and going over some things with them. So, first off, with segments, rays. Segments are parts of a line. So remember, a line goes off into both directions forever. Okay, it's non-stopping. That's why we have the little arrows on it. So with a segment, it's a segment or a part of that line. Okay, so it has endpoints to it. Endpoints are usually labeled with letters: A, B, alpha, beta, anything like that. A ray is part of a line, but there's only one endpoint, so it stops somewhere on the line, but then continues off in one direction. Okay, so it keeps going and going and going and going. Opposite rays are two rays that are in opposite directions that can create a single line. So if you have one line and you put a dot on that line, an endpoint on that line somewhere, you end up creating opposite rays. One's going off to the left, the other one's going off to the right. Okay, so those are your opposite rays. Um, when put together, they end up creating a single line. Okay, not all rays are opposite rays. If they're facing the same direction, they're not opposite rays. If they're not going completely opposite of each other, so if they kind of create a 90-degree angle, those are not opposite rays. When put together, without twisting and turning them, they have to create a solid line with no bends in it. Okay. All right, so take a second with this one. I want you to name a segment. Okay. Now I want you to name, so segments that we have here would be US, SA, UA, AS, AU. Those are all different segments that you have. Um, there are several different ones. The order in which the letters are named does not matter. So US and SU are the exact same line segments. Okay, so the order in which the letters are said do not matter. Let's try to name a ray. So take a second, name one ray. Now, when you're naming a ray, what you want to do is you want to make sure that you name two letters. The first letter will always be the endpoint. So UA, so if you name a ray UA, that means that U is going to be your endpoint and you're going off into the direction of A. So UA, the ray UA, is the same as the ray US because it's the same endpoint, same direction. AS and AU are the same ray. It starts at A, that's your endpoint. Usually the first letter you name is the endpoint of the ray, and then the second letter is the direction it's heading off. And the reason we need that second letter is because what if our endpoint is S? If our endpoint's S and we name it SA, that means it goes off in this direction. And if we name it the other one, SU, it goes off in the other direction. And those, SU and SA, are opposite rays. Okay, so one thing that you'll notice is if you look at buildings and a lot of different architecture, you can see different line segments and forming here. So you see all the horizontal lines, all the horizontal, flooring, roofs for them. Those are all line segments that you have. The columns, they create little line segments for them. So you have all those. There's also skewed and parallel lines that are in that image as well. So parallel lines are lines that are coplanar, meaning that they're on the same plane. You can put them on a sheet of paper, and they'll be flat on that paper, and they never intersect with each other. Okay, they never ever intersect with each other. If you have your a notebook in front of you right now, you'll see the lines on your notebook. Those are parallel. Okay, they're on the same plane, piece of paper, and they never intersect with each other. The ones going horizontal, the blue ones usually. Skew lines are lines that are non-coplanar, so they'll never intersect anyway. So they can't be put on the same plane. So you can't put them on a piece of paper, basically. So if you're trying to draw skewed lines, it's very difficult because you're trying to draw it on a 2D surface. So the easiest way to try to figure this out is looking at your computer screen or your desk. Okay, you take the top edge. Okay, so like the edge that you're up against, you take that edge of your desk, and then you take the back left part of your desk that's going vertical, so the part that's going up and down. As you see, they never will intersect with each other because they're on different planes. One is closer to you, the other one's farther away. If we look back at this image, okay, so you see all of these going horizontal, those are all your parallel lines. And the ones all going vertical, those are all parallel. They're on the same plane, they're never going to touch. Now, your skewed lines would be a line that goes right here along this front side, and then one of the ones going vertical along the back side. So those would be skewed. They never touch each other, but they're never on the same plane. Okay, and remember, we're talking about a line, so it's just the edge of it. We're not talking about the whole floor. We're just talking about this edge right here, and then the vertical line up and down. Okay, parallel planes are planes that don't intersect. So your pieces of paper, okay, so if you look at your notebook, you've got all those sheets of paper. Those are all parallel planes. They don't intersect with each other. They're all separate from each other. If they do cross, they create a line. So if you have two planes that cross each other, they create a single line. Think about the edges of your desk. The top edge and a side edge, they meet at, or the top face and the side face, they meet at an edge, which is a line. Okay. All right. That's it for section 4.